First up, I'm just going to get a sketch of my circle, and I'm told it's centered at the origin. So there are my axes. There's the origin in the middle. I don't know exactly where the points are, but I'm just going to put them. So D and minus D, that would be assuming D is positive. I don't know that, but it's just to get a feel for what's going on. And then let me put another point, say up here. That's going to be my other one, 12 minus D, and then 2D minus 6. Okay, and both of these, this is a radius r in both cases. So there's two approaches now. Approach one is to work out the length of the line, which we know, well, or kind of the length of the line, but use Pythagoras' theorem to say that r squared is going to be the base of this triangle squared plus the height of the triangle squared. And the base is simply 12 minus d, and then the height is simply 2d minus 6. So that's how you work out the length of a line, essentially. Because I've got 0, 0 here, so it's normally the difference between the x's and the differences in the y's, but that is what I have here. It's 12 minus d and 2d minus 6. So I can do exactly the same with the one below. Now this time I've got my base is going to be d, and my height is going to be, well, it's minus d, but it's the same thing when you square it. So I'm going to get d squared plus minus d squared. Okay, and my next step is going to be to just, we don't care about that r squared. Actually, we're interested in what d is. I've constructed an equation that relates those coordinates together. Now, just very quickly, the second approach is to write down the equation of the circle, which is x squared plus y squared is equal to r squared. That is the equation of a circle centered at the origin. But you might not have covered that topic. Of course, you might not have covered this topic up here, but you have to realize to use Pythagoras' theorem. And then actually, in this case, you can just substitute in the x and y, your coordinates, and you would get exactly the same thing. I'm just trying to explain it in a different way. Right, so got to deal with this quadratic now. This is actually a double bracket, 12 minus d times 12 minus d. So I'm going to get 144. Then I'm going to get minus 12d minus 12d minus 24d plus d squared. Okay, that's that first bracket. Over here, I've got 2d minus 6, which is 2d minus 6 times 2d minus 6. So I get 4d squared minus, again, I've got minus 12, I've got minus 24d again, plus 36. And that is going to equal d squared plus d squared. Okay, brilliant. So let's tidy this up. I've got, do you know what? I could just sort of minus the 2d squared straight away, change that to 2d squared. That's just going to save me a bit of time. So I'm going to get 3d squared minus 48d, and then I've got 144 plus 36, that's going to be 180. Okay, and step one of any like solving a quadratic is to try and cancel out common factors. So I can divide through by 3, d squared minus 16d plus 30 is equal to 0. So the approach, oh sorry, I didn't divide by 3 correctly there. That should have been a 60. Just checked my notes and saw that. Whoops. Okay, but everything else is absolutely fine. Now there are numerous ways to get the answer of D here. We're just interested in the sum of the two possible values of D, but I'm going to go with good old factorizing to work out each of them, and then we'll add them together. So both are going to be negative necessarily because I've got a positive here but a negative here. Factors of 60, 10 and 6 jump out. I was going with 12 and 5 to start with. They're going to have to both, they're going to both be even. So yeah, 10 minus 10 minus 6. So we get D is equal to 6 or 10. And therefore the sum is going to be 16. Nicely done.